Hello everyone, in this video I'll be explaining the representations of Turing machines, how we can represent any Turing machines when a problem is asked to solve. So there are three ways we can represent any Turing machine. One is using instantaneous description using move relations. So instantaneous description normally uh, called as ID. So here ID need to be represented for each move while processing the for the processing of the input that is required. So next is transition table, and finally transition diagram. Transition diagram, sometimes it is called as transition graph. Representation via instantaneous descriptions. An ID of a Turing machine M is a string alpha, beta, gamma, where beta is the present state of M and the entire input string is split as alpha, gamma. The first symbol of gamma is the current symbol A under the read-write head. Gamma has all the subsequent symbols of the input string, and the string alpha is the substring of the input string formed by all the symbols to the left of A. So here what I said, any ID is represented as alpha, beta, gamma. Alpha, beta and then gamma, where beta is the present state of the M. This is the present state of M. Okay, and entire input is split as alpha and gamma. In that, the first character of the gamma is nothing but current symbol A. Current symbol A. That is A is, we are going to assume it's the current symbol is the first character of the gamma. Okay, and then this current symbol, how do we identify it is a current symbol? So that is based on the read-write head of the machine. Read-write head is pointing to which symbol, that is the current symbol, and that is always the first character of the gamma. So I have told initially input is split into alpha and gamma. Now we have come to know that what's the first character of the gamma. The following the current symbol, rest will be part of the gamma, and before that whatever character comes, that goes with alpha. Okay, so this is explained by taking the snapshot of Turing machine. So you can see here the read-write head is here, and the read-write head is pointing to the symbol. Which symbol? That is A1 here. Okay, now how do you write alpha, beta, gamma? Alpha, beta, gamma. So what did I say? This is the present state. You can get it from the finite control tool. Okay, so here it is Q3. And what is alpha and gamma? Entire your input is present in the tape. It is present in the table. Entire thing is here, till here it is alpha and gamma. And the first character of gamma can be identified by a read-write head. So following this, that is the from A1 till the last character of that input will be a gamma, and this A42 till here will be a alpha. Okay, now how do you represent alpha, beta, gamma? Alpha is nothing but all these characters till here. Gamma is nothing but A1, A4, A2, and state Q3 is Q. So here you can observe that Q3 has to do the processing by looking at this particular input. That's why Q3 need to be before the current symbol. Okay, Q3 need to be before the current, so that next behavior is based on this, where the read-write head is pointing. Okay, so now as I told how we can write, that I will show with the how we can write alpha, beta, gamma. I will show in the next slide. So here you can see that we have already identified what is alpha, beta, gamma. Okay. So this is what A4, A1, A2, A1, A2, A2. So this is the left sequence. This is nothing but alpha, whatever I have shown in the snapshot of a Turing machine. This is alpha and this is beta and this is gamma. Okay. Next we'll see the next representation. What's the next representation? So the next representation you can see here, that is transition table. Transition table. So how do we represent any transition table? So let us see, let's observe this delta of q comma a, which is gives gamma comma alpha comma beta. What is delta of q comma a is going to give you gamma, alpha, beta. Okay, and how we are going to represent this, that is the future behavior of the present current symbol and the current state. Future behavior of current symbol and current state is defined in this way, that you're going to represent in the table format, like how we have written the transition table for FSM. So now we can write alpha, beta, gamma under the column alpha column and in the qth row. Alpha column and in the qth row. For qth row and alpha column, you're going to write alpha, beta and gamma. What does these indicate? Alpha says that is the what is written in the current cell. What is written in the current cell? So based on the current symbol, what will be written? So sometimes you want to replace A by some other character. Current symbol, if you want to replace by some other character, let's say X, then you can tell that you want to replace that by Q on A, delta on Q on A, it will be equal to alpha. What is alpha here? X. What you want to write after reading this symbol? What do you want to replace? Then place. Now gamma, alpha we have written. Next is about beta. Beta represents after processing this character, which side you want to move, whether you want to take the next step towards left or right. So always remember, you can move one cell to the left or right. So you're going to specify the left or right move here in the beta position, and then always as usual Q on U goes to which state, that you're going to represent using gamma. So this is what gamma, alpha, beta represent. Alpha is the alpha says what is written in the current cell, beta says the movement of the read write head, and gamma says which is the next state you want to move. Okay, that is about the transition table. Next, that for entire Turing machine you can represent a transition table like this, and the state will be like this. The present state will be your row, and all the states you're going to represent here, and Q1 here indicates that arrow representing here says that this is the start state. The circle represent this is the accepting state. Okay, and then these are the tape symbols. What are the symbols that is going to present, or you're going to write, or you're going to use in the symbol tape? Those are blank, 0 and 1. What about blank? Blank is other than the your input character. Okay, which if you are going to use it, then definitely you're going to represent that in the table. Okay, next, how are we going to, what is the meaning of this Q1 non B? So here gamma, alpha, beta. Okay, now while writing, so delta q comma a is nothing but gamma, alpha, beta. Okay, how we are going to write on qth row and alphath column, qth row, that is q1th row, and bth column. What you're going to write? You're going to write what you're going to write it onto the cell. So that is first alpha, next you're going to write beta, that is the state, and the it's not state, it's the movement either to the left or right, and finally gamma. This is what you're going to write here in the cell. If there is a transition happens on each of on the characters, q1 on b, if there is a transition, you have to write like this. See, you can see here some places are vacant, that means there is no transition happening on the this particular state on this input. Okay, next is about the transition diagram. So transition diagram is similar to the FSM. Only the transition labels are differ. That means there, in case of FSM, the transition labels are single characters, whereas here the transition labels are in the triple format. That is, triples are of the form alpha, beta, gamma. What does alpha, beta indicates? Alpha, beta indicates the table symbols, you can see, and gamma indicates whether you are moving to which side, left side or right side. And remember, as I told, you are going to take only one step, either to the left or to the right. So now qi to qj, if there is a transition between qi state to qj, then you have to label that transition with alpha, beta, gamma. And as usual, let me recall, the states are represented by vertices and directed edges are used to represent transitions of the states. Okay, so now if there is a transition between qi state to qj, then the label is of the form alpha, beta, gamma. What is alpha, beta? Alpha, beta are the tape symbols, gamma represent whether it is L or R, left or right. So any transition is represented in this way. This is the state. You remember, we have already explained in the previous case, that's the state, and which symbol you are going to write it onto the cell, and finally the movement. Here, this is a transition diagram for 0 to the power n and 1 to the power n. So you can see the explanation, and you can see the diagram of this, and the explanation of this diagram is explained in the next video. So this transition diagram is for 0 to the power n, 1 to the power n, such that n greater than equal to 0. So you can see, observe here, q1 to q2, there is a transition happening, and the labels are represented as alpha, beta, gamma. What is alpha? What you are going to write it on the, what will be written onto the cell. Okay, alpha is nothing but you are reading which character. Sorry, this is nothing but you are reading which character, currently reading which input character. And the beta represents what you are going to write it onto the cell after reading this onto the current cell what you are going to write. So here it indicates that 0 will be replaced by x, and after that you are taking a right move. Why this movement is required? So that you can process the next character. So this is how you have to indicate the remaining. Let me explain this transition q3 to q5. What is it is going to read? It's going to read the x character, read write head is here. So this is what written here. Okay, read write head is pointing to this x character, and x character is replaced by x itself. That means no change. Whenever you want no change in the particular cell, then you can write the same character. So, and after that, once you finish processing this character, taking a right move, that means you point to the next character. That's what the right movement. If it is specified as x comma L, then what happens? Suppose read write head is here. After that x is changed to x, and then you are taking a move to the left in the sense here. Okay, so this is what the transition diagram. So these are the three representations.